Hello and welcome to another Ginger Mathematician video where I'm going to go through all things today iGCSE speed distance time with a particular focus on distance time graphs and speed time graphs for the iGCSE Maths 0580 course. Right, let's get started. So we have a diagram here which is a speed time graph. It's often quite useful here to underline whether you have a speed time graph or a distance time graph. That's going to change what we're going to do in the question. And it's of the first 15 seconds of a car journey. Now, generally a 1 mark question is exactly what they ask here, which is for the acceleration. So for a speed time graph, they could ask for the acceleration of the car. So all I'm going to do here is essentially work out the gradient. So if I see acceleration for a speed time graph, I'm going to work out the gradient of that particular part of the graph. So in this case, we're looking at the first 5 seconds. So I've got 5 seconds here. And if I look at the height here, that's going to be equal to 14. So to work out the gradient here, all we do, remember, is the change in y over the change in x. So our change in y, so the height of this is 14. And then the length of this is equal to 5. So we get 14 divided by 5. I'm going to put that as a decimal, which is 2.8. Again, you can check that on your calculator. Looking through some of the mark schemes, sometimes they want you to simplify and sometimes they don't. So on the safe side here, I'm going to put this as a decimal. Now, the second question is also very, very typical, which is the distance travelled. So as soon as I see the distance travelled on a speed time graph, I'm looking for the area under the graph. And you're going to see this idea again and again in this video. So how do we work out the area under the graph here? Well, we have a triangle and we have a rectangle. So to work out the area of the rectangle, notice here that the length of my rectangle is the difference between 5 and 15. So that is 10. The height has remained the same, so that's going to be 14. So to work out the area of this rectangle, we do 14 times 10, which is equal to 140. And if we want to work out the area of the triangle, notice here we're working out the area, not the gradient. So I just want to find the area of the triangle, and that's equal to 14 times 5, so base times height divided by 2. And again, you can use your calculator to work this out. I'm going to do this non-calculator style. So 14 divided by 2 is 7. 7 times 5 is 35. So to work out the total area under the graph, so the entire 15 seconds, we just do 140. So this answer here plus 35, and that gives us 175 meters. Generally in these particular questions, they do give you the units to put into the answer, so you don't have to worry too much. However, you are going to see some more advanced questions where you need to work between meters per second, kilometers per hour, and so on. So you can see the answers there for your 3 marks. This is a very standard question I'm starting with in this particular video, and you can see the working needed. Okay, on to our next question, which is a bit more difficult. So again, we have a speed time graph, but I'm going to be highlighting that or underlining that in the exam. And we have the graph here, which is kind of unfinished, but we'll talk about that. The car starts and rests, so 0, 0, and accelerates at a uniform rate. And in the iGCSE, it'll always be uniform for 15 seconds before reaching a constant speed of 30 meters per second. So again, that 1 mark question, which is very, very typical, calculate the acceleration for the first 15 seconds. Well, again, as soon as I see acceleration here, I'm thinking gradient of the first part of the graph, almost always a triangle. So we have here at 15 and we have here at 30. So all we need to do here is change in y over change in x. So we've got the 30 divided by 15. And again, that's going to give us the answer of 2 meters per second squared. Notice that's always a hint in the question here. If we have meters per second squared, that's always going to be an acceleration. Whereas if we're looking at a speed, that's going to be meters per second. And I like this next question. It's really getting you thinking about what's going on here. After t minutes, and the bold letters for a reason here. So we're working now in minutes here, and the total distance travelled is 45 kilometers. Also very, very important. and we want to find the value of t. Well, the first thing to realize here is 45 kilometers. That's the same as 45,000 meters. So we're going to come to that in a moment. My first thought here is, well, if you want to find the total distance traveled, like in the previous question, it's the area under the graph. Now you're probably thinking, well, we don't have two distinct shapes, but let's just work out what we can so far. So we're going to work out the area of this. So we've got a triangle. Remember, it's base times height divided by 2. So we're going to do 30 times 15 divided by 2 to work out the area of this triangle. Again, you can pop this into your calculator or a bit of non-calculator work here, and that's going to give you 225. Now let's think about units here, again important in physics and science as well. We have meters per second here, we have seconds, so this must be in meters, and that's really, really important. So what we want to find is the entire area here is equal to 45,000 kilometers. So the first thing I'm going to do is take away this 225 meters from 45,000. So I then just need to work out the area of the rectangle. So I'm going to do 45,000 meters because that's my total, and take away 225 meters. And that gives me 44,775 meters. Right, so I want this area under the graph here to be equal to 44,775 meters. We know the height is 30 here, so essentially what I'm saying to myself is 30 times something, so that's going to be the length here, is equal to 44,775 meters. Notice we're working in seconds and meters for the moment. So to work out this thing, what's the opposite of timesing by 30? Well, divide by 30 on both sides. So this thing I'm looking for, the length here, is equal to 44,775 divided by 30. And if we pop that into our calculator, we get 1,492.5. Again, think about the units here. This is going to be equal to seconds. Okay, so what I've worked out here, just to show visually what's going on, I've worked out that this length here, so this here is going to be equal to 1,492.5 seconds. Okay, perfect. So what we can do now, because remember we want to find the value of t in minutes, that's why I underlined this. So we need to convert 1,492.5 seconds into minutes. Now how many seconds are there in a minute? Well, we need to divide by 60. So if we divide that by 60 here, we then get our answer of 24.875 minutes. That's not the final answer because we've got this extra 15 seconds here as well. So to work out t, we need the 24.875, and then in minutes add on this extra 15 seconds. Well, 15 seconds here is a quarter of a minute. Quarter of a minute is 0.25 minutes. Add those together and we get to our final answer of 25.125 minutes. For our final answer, so I'm just going to pop down here. Now my temptation here is just to leave it as an exact value because I don't think there's any need for rounding at this particular point. This is a much more sort of complicated question. You can see here, this is question 15, and really gets you thinking about, I know I need to find the area under the graph. I'm kind of working backwards to then find the time. And you can see the working here. I've taken this approach, so this one here, and then use that to then work out what I need to get to 25.125. Right, on to our next question. So this is question 5 here. And again, we've got a speed time graph. I do promise you there will be a distance time graph in this video. For two vehicles, we've got a car and a bus. So notice we've got here the bus traveling at a constant velocity, a constant speed here, which we'll find out a bit later. And again, that 1 mark question, as I've told you, always comes up. Just be a little bit careful in this case. So acceleration, that means we're looking for gradient. But we have to be careful here because we're considering this part of the graph. So the temptation is to use 24 here, but we don't want to use 24. We need to use this length here. Well, we've got 24 minus 10. That's equal to 14. This bottom part is here equal to 18. So our gradient here will be equal to 14 divided by 18. Biggest mistake that's made in this kind of question, again, you can simplify the fraction, but I'm going to leave it. That's 14 over 18. But the biggest mistake is that people take 24 here rather than this length 14. So watch out for that 1 mark. On to part 2. So in the first 40 seconds, the car travelled 134 metres more than the bus, and we want to work out the constant speed v of the bus. So we're going to form an equation here where we want to equal the car distance to the bus distance. So first of all, how far did the bus go? Well, we just need to work out the area of this rectangle. So I just pop this in here. So what's an expression to represent this? Well, the bottom of this rectangle is 40. The height is equal to v. So the total distance travelled will be 40 times v. That gives you the area of that particular rectangle. Hopefully I can delete this so you can see the car a bit later on. And we're told in the question the car travelled more than the bus, so we need to add on 134 here to equal the total distance travelled by the car. Now, next question is, how do we work out the area for the car here? Well, we divide it into 2 separate shapes. So we've got here, we can use this as a trapezium or a triangle and a rectangle. So you can take that approach and you'll see that in the mark scheme. But what I would recommend to do, as long as you're happy with this, is to take the area of the entire rectangle. So let me just show you what I mean here. So for the car here, so work out the area here and then subtract, so using the subtraction method to take away this triangle here. So I'm going to take this more sophisticated approach. If we do this, we get, well, 40 times 24 is the area of the entire rectangle, and then we're going to minus the area of this particular triangle. Now, we already worked out the dimensions in the previous question. This is 14, this is 18, so we're going to take away 14 times 18 divided by 2. I think this is a smoother way to get to our equation. So remember, the left-hand side represents the total the total travelled by the bus. The right-hand side does the car. Now, let's just tidy this up slightly. So we've got 40v plus 134. 40 times 24 is 960. And this here is equal to minus 124. And now we've just got an equation to solve for v. So if we work through our process here, first of all, let's tidy up the right-hand side. So 960 minus 124, 960 minus 124 is equal to 836. Hopefully you're now in comfortable territory. It's like, nice two-step equation, very, very good. Then we've got a plus 134, so the opposite of that is minus 134 on both sides. This cancels, this gives us 40v, and then 836 minus 134 is equal to 702. Just make sure we've done this all correctly. And then we divide by 40. And that gives us 17.5 for our final answer. Perfect. I think there's a mistake made somewhere here. This should be 700. Just check my working as you go through. But you'll get to the answer here of 17.5. And the second part of the question is not really related to what we've seen so far, which is a train takes 10 minutes and 30 seconds to travel 16,240 meters. Notice the units here, seconds and meters, and we want the average speed of the train in kilometers per hour. I've said sometimes they want you to transfer between meters per second and kilometers per hour. Now, some people here just learn the rule off by heart to convert between it. What I find is students often forget that during the exam. So my approach here instead would be, well, I've got 10 minutes and 30 seconds. So that's 10.5 minutes. Remember, 30 seconds is half a minute. And I'm just going to convert that into hours. So the way that we do this is just divide by 60. And you have a calculator in the exam, so there's no reason why we can't sort of exploit that and use it. So we get 0.175 hours. Then we've got 16,240 meters. We want to convert that to kilometers, so we divide by 1,000. Remember, there are 1,000 meters in a kilometer, and if we divide that, we get 16.24 kilometers. And now this is just a very straightforward use of the speed distance time rule. So we want to find the speed, so we need to do distance divided by time. So speed is equal to 16.24 divided by 0.175. Again, let your calculator here do the rest for you. So you got 16.24 divided by 0.175, and that then gives us 92.8. By doing it in this approach, and that gives us all 3 marks here, that then guarantees we've got the right units for the questions. So rather than learning some rule, which obviously you can use here, what's more effective usually in an exam setting is convert to hours, convert to kilometers, and then you can use the formulae, safe in the knowledge you don't have to do any changing of units later on. Okay, so those are the answers for the questions you've just seen. And if this content has been helping you so far, then please do think about subscribing to the channel, because you'll find tons of iGCSE maths videos. I think it's up to about 120 videos to cover all things iGCSE maths 0580 and 0607. Right, on to our next question. So a nice little twist here with our speed time graph, which is now we're looking at the deceleration of this car in the final 8 seconds. Acceleration and deceleration work in exactly the same way. So we're still looking for that gradient. And again, we look at the height here, which is equal to 12 from here. And then we've got this part here, which is 8. So we're going to do here 12 divided by 8. Now, what I found really weird in the mark scheme, in one question, not simplifying was absolutely fine, whereas here they actually do want you to simplify, which if we do, we'll get 3 over 2, which is the same as 1.5. So when we look at the mark scheme a bit later on, it gives you 1.5 or 1.5, even though in the previous question, they were happy not simplifying. So if in doubt, just simplify your question or put it into a decimal as well. Now we want the total distance travelled during the 24 seconds. Same approach as before. We're going to work at the area of the rectangle, area of the triangle. So here we've got 16 times 12. In this part here we have base times height divided by 2. So that gives us 48 here. Again, you can check on your calculator. This is 192. So if we pop these together, so the total area of the rectangle, 192, add on 48, and that will give us 240 meters. And this is a much more standard question. Again, even though it's question 20, so it should be harder. Again, if you know these key ideas, then you can get these right again and again. So those are the answers here. As you can see, as I mentioned earlier, no indication you can leave it unsimplified. On to our next question, which is a distance time graph, and I've drawn the graph for you here already, but I just want to go through explain how I've got these 3 marks. So Annette cycles a distance of 70 kilometers, so that's the final distance. You'll notice here, this point here will be at 70 kilometers. Leaving Midville, she cycles for 1 hour 30 minutes, so that's 1.5 hours, at a constant speed of 20 kilometers per hour. So if I want to find the distance that she travels, remember what we need to do here. So distance is equal to speed times time, so 1.5, and that will then give us 30 kilometers. So when I'm plotting this on my graph, I start at 0, 0, so where she actually begins in Midville. You know she's going to arrive 30 kilometers. So here's 30, so just pop this in. This is 30 in 1.5 hours. So this is here 1.5. So I draw a straight line going all the way upwards, as straight as you can. I don't have a ruler here, until you get to 30 and 1.5. Then she stops for 30 minutes for a rest. So she's not traveling anywhere at that point. So that's going to be a straight horizontal line until we get to 2, because we're doing 1.5 plus half an hour, 0.5. That gives us 2. And this is the tricky part at this point. So then she continues the journey at a constant speed of 16 kilometers per hour. So what I've done here is she has 40 kilometers remaining, because we have 30 kilometers here and you've got 70 kilometers, and she's traveling at 16 kilometers per hour. So to work out the amount of time passing here, you do distance divided by speed. That gives you 2.5 hours. So now I know that my next point is going to be 2.5 hours more than 2, which is 4.5. So if I pop this in here, this is 4.5, and we know she's at our destination once she's achieved 70 kilometers. So I have this point already. I know she's going to finish at this point, and then I just draw a straight line in between. This will then imply that the gradient here will be equal to 16. Once we've got that, makes it very easy to do the next part of the question, which is the average speed for the whole journey. So to work out the average speed here, we simply use the same formula. So we're going to do total distance, so using the word total now instead, divided by total time. And we know that from the calculation we just did here. So we know total distance is 70, the total amount of time taken is 4.5, and we simply pop that into our calculator. So 70 divided by 4.5, that's then going to give us 15.55 ... So I'm just going to round to 15.6. By doing a really clear diagram, labeling the y-axis and x-axis with these values we found, it makes then subsequent questions much more easy. So you can check your answers there. I think for 6 marks that's quite generous, but then take these marks because it could make the difference between an AA star or a B and an A. And on to our next question. So this time we've got a speed time graph, always good to monitor. Is it a speed time graph or a distance time graph? And we need to complete the statements here. So the first thing is section something cannot be correct. Now, one thing to be aware of, we can't go back on ourselves. You can't go back in negative time. So if you ever see something where you're going backwards in the speed time graph, that simply can't happen. You can't go backwards in time. At least we haven't invented it yet. So this part here is going to be the wrong part. Section D. Constant speed. Well, constant speed will always be on a speed time graph, a straight horizontal line. So which part is a straight horizontal line here? Well, that's part B. So we pop in B. And deceleration, we saw this in the previous question, is when we're actually got a negative gradient. Where do we have a negative gradient? Well, that's at part C. So that's fairly straightforward. Section A, again, is working out acceleration. You've seen these questions again and again. So to work out acceleration at A, we simply look at the height here, which is 10. We look at the length here, which is 30. And make sure you divide the right way around. Okay, height divided by the length. So we're going to do 10 divided by 30, which can be simplified to 1/3. And then the distance travelled in the first 30 seconds of the journey. Again, read the question. We don't want the total distance travelled, just the first 30 seconds. That's going to be the area of this triangle, which gives us 10 times 30 divided by 2. And that's going to give us the answer of 5 times 30, which is 150 meters. Meters already given in the question as well. Okay, so those are the answers here. These are all the questions I could find on speed, distance, time in the last couple of years of papers. So it's very, very useful that you have those. If you want to get up to speed on all things upper and lower bounds, which is a topic some students just find tricky or hasn't been taught as well as they had hoped, then check out the video right in front of you, because this goes through, again, just like this video, good 30 minutes of upper and lower bounds questions. So you're ready for that exam when it comes.